Hey Pre-Calc gang, time for lesson 10.2 as we start our discussion of conic sections here with today focusing on circles. First of all, just to identify these things called the conic sections, all based on slicing and dicing a double cone. So you can see the various shapes that are produced. Today we're going to talk about a circle that would be just a straight, kind of a parallel slice through the cone. If it's a little bit more of a slanty slice like this, it would produce an ellipse, and then a slanty slice like this, a parabola, and then lastly we have kind of a vertical slicing which would produce something called a hyperbola. But as we mentioned today, we're just going to primarily focus on circles. So everyone, I think, knows the definition of a circle up here. Set of all points that are equidistant from a given point, which is called the center. Now we have two forms of circles that we'll be focusing on quite a bit, the standard form and the general form. Standard form is our preferred format that we like to get it in because we can then identify the center and the radius. So for instance, in this case, let me just get a nice color here going. The center is always designated by H and K. And the radius then, of course, is r. And typically in the standard form, notice it's r squared, so we have to figure out what just plain r is. Now the general form, which sometimes we're given in this case, and a lot of times we like to translate it into standard form, but here's the general form. Again, notice a couple of key things. The coefficients in front of x and y, most of the time they're just 1, but even if they were the exact same number, that would still identify it as a circle. Watch out when these two coefficients are different, because then it will no longer be a circle. And of course we have some other coefficients as well. But again, this standard form is really the key thing. We'll be, in all of the conic sections we look at in this chapter, we'll be looking at trying to get stuff in standard form almost all the time. Alright? So we're going to do some easy examples here to begin with. And first of all, alright, thanks Joe. That's fine. You get to be in a video now, Joe. Did you know that? You want to say hi? Say hi to everybody. Just say hi.
Why?
Because then you get to be in a video. How about that?
Okay.
For pre-calculus. So hi.
Hi.
Alright, thanks Joe.
Yep.
See ya. Alright, that was our special guest speaker popping in on me here, but that's good. Alright, so here's our first example. We want to try to write the standard form equation and graph the circle with this particular center and tangent at x equals 3. So let's graph this point first of all. So negative 1, 4 is going to be up here, right about there, I guess, right? And if it's going to be tangent to x equals 3, well, here's the point. X equals 3, of course, is a vertical line that goes like this. So telling us that means going over this point. That tells us right there that my radius is going to be 4, because I have to count over that many just to get to my particular radius. Now really that's all I really need now in order to write my equation. So here it is. I can write x. Now minus negative 1 is the same as plus 1, and I'm going to square that. And then my other center point is y minus 4. Again, I have to square that expression. And then, of course, it's going to be equal to not just the radius, but the radius squared. So there it is right there. That's the equation of that particular circle given by this situation here. So it kind of was helpful to have the graph there to reason things, something. All right, next one. Here's pretty much the meat and potatoes of the chapter here. We're going to be doing all kinds of problems like this where you're going to be given a certain conic section. It is in general form is what we call it now. We want to get it in standard form so we can identify some more of these key points. And I'm going to give you some initials here because this is what we're going to be using almost all the time. CTS, that stands for completing the square. Remember we did that last quarter when we were primarily looking for another way to solve quadratic equations. But here it also comes in handy in picking out what the center and radius would be of this particular circle. So let's get to work on this one. First thing I want to do is kind of group my x's together. So I have x squared plus 6x like that. I'll get a different color here for my y values, and I'll have the y squared minus 4y here. And meanwhile, all this stuff is going to simply be equal to, now I like to get rid of all the constants or single numbers there, so I'm going to say it's going to be equal to negative 4. Alright, first of all I'm going to work with my x's here. Now if I complete the square, you may remember that I always focus on this value right here. We call that the linear term. I take half of that and then I square it. So what I'm going to end up with here, half of this is 3, 3 squared is 9. So I'll have x squared plus 6x plus 9. Meanwhile, if I added 9 there, I better also add 9 over here, right? Okay, and whenever I do that, that should give me a perfect square, and sure enough it does here too. This is going to be x plus 3 squared. Get back to my pen color here. Same thing over here. Again, I'm going to focus on that 4, that negative 4. Half of that is negative 2. Negative 2 squared is plus 4. So I'm going to add 4 over here as well. Meanwhile, I'm going to end up with y minus 2 squared. That's my perfect square there. And on the right hand side it's going to equal, notice the 4's cancel out, and it's just going to equal 9 over there. So now I can clearly identify what my key features are. It looks like my center is going to be the point negative 3, 2. Again, a plus sign essentially means the opposite of that. Minus is our preferred or default way of doing things here. So the center is that, and the radius is not 9, but the square root of 9, which is 3. So that's just a real central skill that we'll be using a lot in this particular chapter. Idea here now, and this is kind of cool if you think about it. I can give you 3 points here that are on a circle, and then you should be able to tell me what the equation of that circle is in standard form. So this might take a little while to slog through, but we'll try to go fairly rapidly. You might recall that that general form of a circle was x squared plus y squared. There could be coefficients in front of those two, by the way, as long as they're the same value. Plus dx plus ey plus f equals 0, like that. Now what I'm going to do is substitute each of these 3 points in there. I'm going to end up with essentially a matrix type situation, and we're going to do some matrix multiplication to help us find the answer to this. So first point I'm going to start with, I'm going to get a different color here, and so I'm going to start with a point 1, 3, and basically I'm just putting substituting 1 in place of x all the time and 3 in place of y. So here's what I'm going to get. I'm not going to say too much about these as I do it. Hopefully you can kind of follow along here. There we go. So I end up with, let's see, I think I'm just going to do this and show you what I'll end up with toward the bottom here. Alright, another color here. Hopefully this will show up. Another point I want is 5, 5. So if I sub that in for everything, I'm going to get 25 plus 25 plus 5d plus 5e plus f equals 0, and that's going to simplify. Well, I'm going to write that down later. Yeah, that's what I said. And lastly then, my last point is 5, 3, I think. Yeah. And once I write that all out, that's going to be 25 plus 9 plus 5d plus 3e plus f equals 0. Now, we've done some stuff like this before. Notice if I focus in on essentially these coefficients and variables right in here, so d, e, and f, do you see that I could make like a 3 by 3 matrix out of all those? And with my answers here, I can make a 3x1 matrix. So it's actually going to look something like this. I'm going to get a whole new color out here. See if we can combine these a little bit. Again, I'm just looking at my coefficients. So essentially I'm looking at this for now. And so it's going to be 1, 3, 1. Again, looking at those coefficients there. And 5, 5, 1. And 5, 3, 1. That's my coefficients. And you might recall, in order to solve these, kind of going backwards, I need to take that to the -1 power, the inverse of that, and then I'm going to multiply it by, and here's something I didn't do, but I think you can figure this out. Do you see over here 1 and 9 is 10, but I want to get that on the other side here because I want these things to be by themselves. So my 3x1 matrix will be -10, -50, and -34. And actually, when I do the inverse of this, the values that I get will be this. Let's see, -6, -8, and +20. And so that then should be not X, Y, and Z, but in this case D, E, and F. And so then when I write my final answer, I'm going to go to another slide. My general form answer then will be x squared plus y squared minus 6x, whoops, minus 8y plus 20 equals 0. It doesn't look like anything's too complicated about that. But remember, we'd like to get this probably in standard form so we can pick out the center and radius. I got to hustle here a bit. So anyway, I'm going to complete the square again. I'll just kind of get you started on this. So x squared minus 6x over here. This will be y squared minus 8y here. All this is going to equal -20. Just suffice this to say, I don't want to take up too much time here. This is going to end up to be x minus 3 squared plus y minus 4 squared. And after adding and subtracting some things and simplifying, I'm just going to end up with 5 here. And that means that the center for this circle is going to be 3, 4. Remember, the minuses we like. That's kind of our default thing. And then the radius is going to be not 5, but the square root of 5. The square root of 5. So that's quite a bit of stuff to digest with an ode to circles, a lot of weird circle designs and everything like that. And we'll continue to work on this in class. We'll see you guys then.